Hey guys, Kenny here. So today we're going to go ahead and take a look at oil. We'll talk about its formation, products come from it, and the types of oil. Uh, we've already kind of gone over the different groups that we're going to look at in this non-renewables unit, the different types of fossil fuel, of which oil is one, as well as kind of briefly touching on nuclear. We'll cover more of these later, but let's go ahead and jump right in and look at our essential questions. Number one, oil and natural gas form from the remains of what sorts of organisms? Number two, what has to happen to organic matter in order to produce hydrocarbons? Number three, what types of rocks serve as reservoirs for oil and gas? And number four, how do tar sands form? Now, the first thing we have to start realizing is what fossil fuels are. And we talked a little bit about this last class. But in 2 minutes, I want you to go ahead and try and list as many fossil fuels as possible without consulting any reference materials, your textbook, any online websites, and just see how many you can go ahead and come up with. So go ahead and pause the notes here and see how many different types of fossil fuels you can come up with. All right, how many did you come up with? Hopefully you came up with a good list. Now, if you have another friend that's in this class or is taking environmental science with another teacher, go ahead and pair up with them or group of students, that's fine, to compare your list and see if you have anything they don't and they have anything you don't. And then let's take a look at a little history of fossil fuels in what I call Fossil Fuels 101. All right, so compare your lists and then we'll go ahead and watch the film. So if you still need to compare your list, go ahead and pause and then we'll come back to this. Okay, welcome back. Let's go ahead and get started.
Fossil fuels. Fossil fuel is a term used to describe a group of energy sources that were formed from ancient plants and organisms during the Carboniferous period approximately 360 to 286 million years ago, even before the age of dinosaurs. At that time, the land was covered with swamps filled with organisms and plants. As they died, they sank to the bottom of swamps and oceans and over millions of years started decomposing under layers of sand, clay, and other minerals. Different types of fossil fuels formed depending on the combination of organic matter, temperature, time, and pressure conditions while decomposing. There are three major types of fossil fuels: coal, oil, and natural gas. Coal was formed from ferns, plants, and trees, which hardened due to pressure and heat. Oil was formed from small organisms like zooplankton and algae, where pressure caused the more complex organic matter to decompose. Natural gas was formed by the same process as oil, only it was exposed to more heat and pressure, causing it to further decompose and turn into a gaseous form. Fossil fuels are sought-after energy sources because they have a high energy density. They are the world's dominant energy source. Fossil fuels have a variety of applications from electricity production to transport fuels. They can also be used to make a variety of common products, from plastics to cosmetics to even some medicines. These resources have powered industrialization over history and continue to do so today. Fossil fuels can be an abundant and cheap, or in some cases, a scarce and expensive form of energy, depending on geographic location. For this reason, geopolitical issues arise due to scarcity caused by the natural geographic allocation of these highly valuable resources. Fossil fuels are considered non-renewable resources because they take millions of years to form, which means that once they are used, the resources will not be replenished in a human lifetime. The gradual depletion of the most accessible fossil fuel reserves have forced companies to develop technologies for extracting more challenging or unconventional reserves. In many cases, this means additional safety and environmental concerns as well as higher costs. Fossil fuels are also the largest emitters of carbon dioxide, a greenhouse gas which causes climate change. In addition, their production causes both environmental and human health issues. These concerns have triggered society to look at alternate sources of energy that are more environmentally sustainable and renewable. That's fossil fuels.
Okay, so some of that is not new. We talked about it before, but I think it's good to review where they come from, how they're created, and I think you should know those types of things if we're going to talk about the amount of energy that comes from them in terms of net energy, as well as why they're non-renewable. Okay, so the list that they gave us includes coal, oil or petroleum, and natural gas. But there are other non-traditional fossil fuels that we're seeing increasingly extracted because of the limited availability of those primary three. It's not that we're going to run out, remember, but it's how easy is it to get to them and how easy is it to remove them from the ground. So we're going to also take a look at oil shale, oil sands and tar sands, shale gas, and methane hydrate. Now, one of the terms they use there that we've been kind of using but haven't really defined strictly is the term non-renewable. Fossil fuels are in a category known as non-renewable resources, which means they are consumed by humans faster than they can be replenished through the geological processes. Because remember, it takes millions of years to go ahead and replenish these stockpiles of fossil fuels. So fossil fuels are produced by geologic processes acting on organic matter. What organic matter depends on whether it's coal, oil, or natural gas. And this happens over long periods of time, typically hundreds of millions of years. And with as short as the lifespan is for humans, that means that it's not going to be soon before we make more in terms of the lifespan of our populations. Now, conventional crude oil is abundant. There's a fair amount of there, and it has a medium net energy. But the biggest drawback when we start looking at fossil fuels like crude oil are that it has a lot of pollution side effects, causes air and water pollution, and at the same time releases greenhouse gases into the atmosphere, which cause climate change. Now, unconventional heavy oil from oil shale rock and tar sands exists in potentially larger supplies across the planet, but has a much lower net energy and a much higher environmental impact than conventional oil. So when we start taking a look at the availability of these particular resources, we have to be careful in balancing the net energy of these different sources. Just because they're there doesn't mean they're worth their extraction in terms of their environmental impact and the cost to go ahead and get them. So, when we start talking about this, what exactly is oil or petroleum? Well, it's a liquid hydrocarbon. You may remember in your biology days talking about these organic molecules, the four groups of macromolecules, your carbs, lipids, nucleic acids, and proteins. When you start taking a look at carbohydrates and lipids, they were all made up of CHO, carbon, hydrogen, and oxygen. And the remains of these dead animals, in particular, and plants, get compressed into what is going to form the hydrocarbons of oil or petroleum. So, again, we're really going ahead and taking a look at carbon and hydrogen as being the two primary, if you remember, especially when we started looking at lipids. Petroleum can be extracted from rock and refined to produce fuels and chemicals, like we saw in our little video yesterday when we were taking a look at the different things that can be refined out of petroleum. We looked at the fuels that we put in our gas tanks, so gasoline making up about half of it. We also go ahead and take a look at things like rocket fuel. We have lubricants. There are a whole bunch of other products that can be produced by refining petroleum. Now, most of what we kind of trade on the global market is going to fall into a category of light crude. Now, this is a liquid petroleum that has pretty low density and flows freely at room temperature. So it's not very viscous and has a low specific gravity due to the presence of high portion of lighter hydrocarbon fractions. What does that mean? So hydrocarbons are rated based on how many carbons are in the chain. And when you're at the gas pump, you probably notice that they call them octane. What kind of octane fuel it is? Well, octane refers to the fact that there are 8 carbons in the chain. That's what makes it octane. And the percentage you see is how much of the gasoline you're putting into your car is octane versus nonane, decane, septane, sextane, all the other different molecules that could be mixed in. And the more energy they do to refine that, the more pure your gasoline is and the more of its octane. So the higher percentage means more of them are the same size molecule, which means they're going to burn at about the same temperature, which means you're going to have fewer pollutants when you go ahead and use that in your vehicle. Okay, now it generally has what they call a low wax content as well, which also is going to keep your car a little bit cleaner and it's going to make it have fewer problems in terms of the engine. So light crude oil receives a higher price than heavy crude oil because of how it's considered more clean and more efficient in terms of burning for your automobiles in particular. Okay. And so in terms of the commodity market, it's going to have a higher percentage of the gasoline and diesel fuel when converted into products at an oil refinery. And one of the more famous ones is sweet light crude from like Western Texas Intermediate, and that's used as a benchmark for oil pricing. So if you remember um, the old TV show and taking a look at that Texas tea, you may remember that, and so that's where that comes from. Okay. The other category is heavy crude. Now, as we mentioned before, the heavy crude is not going to be as valuable as the light crude because in terms of the refining process, you're going to get less that's going to produce the gasoline that we typically want for automobiles. It does not flow easily. It tends to be more viscous, and this is why it's referred to as heavy, because it has a heavier density, greater density, I shouldn't say heavier, and greater specific gravity. That higher than that of light crude oil. So heavy crude oil has been defined as any petroleum with an API gravity less than 20% of its API gravity, less than 20%, 20 degrees. If its API gravity is greater than 10, then it's lighter and floats on top of water. Okay, so heavy crude oil will actually sink in water, and therefore that's why they call it heavy. So heavy crude oil has more negative impact on the environment than its lighter counterpart, since its refinement requires the use of much more advanced techniques and the use of contaminants. Okay. So when we start looking at the production of oil, whether it's heavy crude, whether it's light crude, we start thinking about it in terms of the process that we went over last class, and I want to go ahead and go over that again today. Okay. If, according to the U.S. Energy Information Administration, we are starting primarily with tiny sea plants and animals that died and were buried on the ocean floor. And over time, sand and silt builds up on top of them, pressure builds up, heat builds up from the internal part of the earth, and then we end up going ahead and producing these oil and gas deposits. Today, we go ahead and drill through all that sand, silt, rock to go ahead and get to those oil deposits, and we extract them, and then we go ahead and refine them. Now, hopefully you remember the carbon cycle from your biology days, and we can trace the carbon from the atmosphere to the ocean into the marine organisms, and then it gets trapped there in the form of these fossil fuels. But when we burn those fossil fuels, it gets released back into the atmosphere. And when it gets released back into the atmosphere, now you have higher CO2 levels than you would have otherwise. Okay. So we need to kind of think about the fact that this oil and natural gas that's buried there is actually a carbon deposit in terms of our climate carbon impact for gases. And so that's something to kind of keep in mind. And when these fossil fuels are burned, carbon dioxide is going to be emitted. All right. So we need to start thinking about this in terms of oil and gas formation. So we'll go ahead and watch this and we'll talk about it at the end.
What drives our cars, buses, and planes? Powers our electricity and allows us to cook our food and heat our water. Most of today's energy needs are met by fossil fuels like coal, oil, and gas. These unique, high-energy fuels are non-renewable resources that took millions of years to form. About 2 billion years ago, marine organisms like algae and microscopic animals and plants died and settled on the ocean floor. Beneath other sediments in the ocean, and in the absence of oxygen, these fossils changed into a substance called kerogen. Under heat and pressure, kerogen gradually changes into oil or gas. The whole process usually takes at least 1 million years. At the molecular level, oil and gas are hydrocarbons made up of hydrogen and carbon atoms. The constant pressure and movement of the Earth's crust squeezes oil and gas through the pores or spaces within rocks. Some oil and gas reaches the Earth's surface and seeps out naturally into land or water. Often it is trapped beneath the surface by impermeable layers or rock structures, like faults and folds. Within the crust, oil or gas deposits build up and form reservoirs. Reservoirs are like vast sponges filled with oil and gas. They can be as large as a city. To find oil and gas deposits, geologists use a number of different survey techniques, including seismic surveys, gravitational surveys, and geological mapping. Seismic surveys use reflected sound waves to produce a 3D view of the Earth's interior. New technologies, such as four-dimensional projections and sophisticated graphic renderings of rock structures, are improving the way we find conventional oil and gas deposits. Energy resources that are currently difficult or expensive to extract are called unconventional oil and gas. In a world with limited energy resources, people are looking at more efficient ways of tapping into unconventional oil and gas, or at alternative and renewable sources of energy from biofuels or the sun. What do you think will be the energy sources of the future?
And that's what we're going to talk about as we go through these next couple of classes, okay? So we'll finish going over the non-renewables, and then in another unit, we'll go ahead and talk about the atmosphere, climate change, and then we'll look at the potential solutions in terms of some of our renewable resources. All right, that's all I've got for you guys. Stay healthy, stay safe, and I'll talk to you soon. So long.